Hey guys, welcome back to the Hewlett-Packard 8662A repair series. When we last left off, I had installed a new A4A7 AGC board. And it eliminated my number 10 error, which was causing all sorts of problems with the output level, had no AM modulation, could not vary the output level very well, and we had clipping. So that, although that worked, I was curious to see if I could fix the board that originally came with it. And I had seen a number of warnings in the service info about this chip being sensitive to static electricity as a CMOS device, etc. And it being bad seemed to me would account for the issues I was seeing. So could some of these other parts, but I decided to gamble, follow my intuition, and purchase a replacement chip. I looked around on eBay and found these guys. See, the original was an Analog Devices 7520. What I found was a National Semiconductor DAC 1020, which was much newer, came out, this one was made in the early 2000s, whereas these originals were made in the early 80s. And the National Semiconductor replaces several analog device chips, a 7520, 7530, and maybe some others, and it seemed to be a little, have a little bit better specs, more rugged. So I replaced it. It was pretty easy to do. It's just a double-sided board. I laid on, rather than desoldering all these, I laid on extra solder and put a small screwdriver on here under this, heated up all the pins on one side, pried it, did the same on the other side, went back and forth a couple times, the chip just fell right out. Then I used some desoldering braid, cleaned out the holes, and popped a new chip in and soldered the pins in one by one. So, let's pop this guy in and see if it does a trick. So here's what I'm hoping. One, it'd be nice to fix it so I'd have two good boards and I could probably just put one right back up on eBay and sell it. But also with this replacement board, there was still one lingering issue. I noticed as I would change the frequency from 1 to 2 to 3 to 4 megahertz, the output level varied a little bit. Likewise, when I would sweep frequencies over a wide range, the output level was undulating as the frequency changed. It's not supposed to do that. It's supposed to be rock steady output level. And this board, I believe, is responsible for that. It has a feedback loop. So I'm thinking that maybe this board works better than this board, but it still has an issue. So maybe if I repair this board, all my problems will go away. Let's pop it in and see if that's the case. I installed the board with the new digital to analog converter in it. Let's see what effect that has. No error lights. That's a good start. And hey, I'll lower the frequency a little. We don't have clipping. We don't have clipping. Fantastic. Let's see, can I change the output level smoothly? I sure can. Amplitude modulation. AM. Hey, how about that? Well, it looks like my intuition paid off. Replaced the digital analog converter. Seems to have fixed this board. It also means maybe I could have saved myself a bunch of money if I tried repairing this board instead of buying another one. Awesome. Now the other issue. What about the amplitude varying with frequency? Let's see. Crap. it is still varying with frequency. So I'm going through 1 megahertz increments, and it is jumping around. Let me set up sweep and see what that is like. Let's see, so I gotta set up the sweep from 50 kilohertz to 50 megahertz. And oh yeah, my goodness, that amplitude is jumping all over the place like crazy. That is terrible. Wow, that's a cool display though. So that illustrates the problem extremely well, I think. That should be flat across all the frequencies. Huh. Also curious. No error lights on the front of the device, but we have some error lights inside the device. And they're flickering. Some of them are flickering. This one's just barely flickering. These are on somewhat. I don't know where that sweep rate. Oh yeah. The intensity of the LEDs changes with the sweep rate. And there's 2 more over here. So we have a total of, oh, that one barely is lit. 1, 2, 3, 4, 5, 6 LEDs with some indication of error, but no error on the front of the device. And these errors are transient. And what are they? Well, there's one on the N-loop divider phase detector, and on some loop phase detector pre-tune, and fractional N-loop phase detector. These are the types of errors I've seen other folks have with this device once they got them working. This is the kind of stuff I was anticipating having to deal with. These are with the phase lock loops and the VCOs and whatnot, the ECL dividers. I also, there's a good chance that these would go away if I went through the full calibration setup procedure. See, I've just been inputting the kinds of values like I would typically use. I have no use for this thing, say up to 1 gigahertz, 5, 6, 7, 800 megahertz. But to fully spec this device out, calibrate it, whatnot, it should be. I don't quite have the gear to do all that, but I can do some of it. I think I very much need the extender cards to do that. Basically, the procedure from what I've seen involves you input certain values on the front panel, certain frequencies, certain modes of operation, and you check test points, and you tweak little trimmers to get things within spec. That's why I got that voltmeter, the high accuracy voltmeter. You might need a spectrum analyzer for some of the stuff that I can't do, but it seemed like the VCO kind of stuff, the loop stuff, a voltmeter was sufficient. So I might just have to go through and do that. I'll need to see if I have to use extender cards or not. So interesting that it has this problem, but it's not because of that board. Both boards are now behaving the same way. So what could the problem be? Yeah, we have these error lights, but none of these errors all have to do with frequency and phase. There is an output detector that feeds back into the AGC. So it would be interesting to get the extender card and monitor the voltage, see what is that voltage that's feeding back into that AGC loop. Also curious, it seems like the problem does not exist below 1 megahertz. So let me change the sweep to go as low as I can, which is 10 megahertz for the start, sorry, 10 kilohertz for the start. And it'll stop at 1 megahertz. And yeah, notice how it's basically flat across. Camera will focus. There we go. It's a little bit of a discontinuity where the sweep starts over, but I think we can probably ignore that. But if I change that stop frequency to say 10 megahertz, now we get the waviness. And error lights start coming on the device. I put that stop frequency back at 1 megahertz. Well, there are some error lights still, but less. It looks like we just have these two. So that's why when you go through the setup procedure, they have you input certain specific frequencies and check things. Because of the nature of the way this works, where they have different VCOs and mix the outputs together and this and that, there's certain key frequencies that you can use to indicate if things are working right or not. I suspect that I'm getting these errors only on certain frequencies. So why would the output level vary if the AGC circuit's working fine? Well, one, maybe it's not. Maybe the error is still somewhat in that, but not on that card. I can't imagine, because both cards exhibit the same behavior. Could it be a problem with the detector pod itself, or whatever, however the detector works? Maybe. But we definitely have this, you know. Let's just not ignore the error lights, you know. So why could it be varying? It could be varying because, okay, I think I'm sweeping from 10 kilohertz to 1 megahertz, or whatever I'm sweeping, 10 megahertz to 50 megahertz. Maybe I'm not. Maybe that is not a smooth frequency sweeping. Maybe there are places where the frequency is jumping, or we have phase problems or jitter, which would be really bad if I'm going to try using this for doing alignments, because maybe it's not doing what I think it's doing. So we really have to address these error lights. The fan is just the standard, I think it's 5 inches or something like that. Fan, it runs directly off the AC line. There's no speed control with a temperature sensor or anything like that. It's just on. It's 35, 37 years old if it's the original. I don't doubt I can get a new one that would be quieter. I just want to make sure I get a similar CFM, or whatever that volume is for the amount of air that moves. It looks like I can maybe get at it by just removing these screws, and maybe I can get everything out just from the back without having to disassemble this thing. On the other hand, I do have to hook up power to it, so maybe I do have to do a little bit of surgery to get at it. There's a very lengthy parts list for this device. I haven't found the fan in that parts list yet, but I'll keep looking. Maybe I can get the specs on it if I do. But that looks like it's fairly easy to replace. If I can get this working silently and working a little bit better, I definitely want to I'll probably just replace both of these units, and maybe be selling both of these units and replace them with this guy if I can get it working a little bit better. That's going to be it for now. What I'm going to do is take some photos of the situation and post them in an online discussion forum for vintage Hewlett-Packard devices. These are the seasoned pros who seem to know more about the stuff than anything, and see if I can get some advice. Just from me searching around, I haven't seen anybody describe this particular error, so we'll see where we can go from there. So that's going to be it for now. Hopefully I'll pick up when when I'm ready to repair this and maybe replace that fan. As always, thanks for watching.